Hi, everyone. My name is Ian Johnson. I live and code in San Francisco, but on the internet I go by Ngelot. It's my personal website. I've been coding or interested in graphical coding since I was like knee-high. Been doing it professionally for a little while, studied a lot in school, and for the last year I've been doing a lot of SVG development with D3.js, primarily for data visualization, so shout out to HighCharts. I'm working with a group of friends, a couple of which are here. We're starting a data visualization design collective, where we plan to do a lot of interactive D3, SVG, and probably some other graphical web standard work. And a lot of what I do this work in is lately in a project I'm working on called Tributary, for exploring these graphical web standards, because they're developing very fast. Every day they're becoming more useful across more browsers, across more operating systems, and we can do a lot more of the things that people have been doing since the 80s or even earlier. In the browser, you can just write in some JavaScript and share it with everybody. So today I want to show you a bunch of examples of different ways that I use this project to explore these things. But before I start, I want to give a little bit of, or a lot of credit actually, to the people that inspired this. I'm sure many of you have seen Brett Victor's Inventing on Principle talk. If you haven't, please YouTube this after tonight and watch it. It's very inspiring. And when I first watched it, I was like, this is awesome. This needs to happen. He didn't release any code with it, but a Italian researcher named Gabriel Florit did an implementation of some of these components and open sourced it, and it's now called live coding. It was called Water. And I forked this on GitHub so I could start playing with it and doing what I wanted to do. And I think I want to credit him with enabling this whole thing to go. So I'm going to show you a lot of examples, probably pretty fast. Hopefully, you'll see what we see in this. And if I'm going too fast, just keep in mind that you can play with this yourself. The link is just ngelot.com/SVG Open 2012. And all of these, it's all open source. And actually the code for each example is, it's a live code editor. It's right there and it's stored in GitHub gists. So it's all made to share and fork and play with. So I want to start with some examples which are based on data visualization, because this is the professional application, you could say. And it's, I think very interesting right now what we can do. Start with the most simple thing, of course, a bar chart, and how this might help if you're prototyping a chart. I mean, this is all D3 code, right? It's not too much, but you play with some data, and you can play with the numbers, and you can interactively see how your chart's going to behave, and then you might go over, oh man, I don't want that to happen. This is because I hard-coded what it's scaling to. Really, this should be like that, right? So now if I go over, it'll scale to that. So this is the kind of thing where if you're interactively playing and seeing what you're doing as it happens, you discover things that you might have missed in your save and restarts. Another thing that can be a pain to deal with is labels. I mean, these are centered and nice, but sometimes they're long and you want to maybe rotate them, and then you want to rotate it the other way because you forgot which way is negative and positive. It happens to me all the time, so you can do that. Besides bar charts, you might want a line chart. This is a simple one that is part of a project we did to show stuff for our D3 group in San Francisco. So these are events that we had, and this is member growth. So we hit 500 members fairly recently. And one little thing I want to show here is placing all these labels, right? This is pretty custom placement. Can be a pretty painful process in most cases, but if I just take away the mouse interaction and show all the labels at once, it's kind of crowded. But one nice thing about this interactive thing, like to get them where I wanted, I could actually, like make this sort of semi-data and then manually place it. So it's somewhere like in between coding and Illustrator, right? Like if you were to do this in Illustrator, then you'd have to do a lot of translation and dealing with that. So I'm all about these kind of quick, play with it, fix it, get it working. Great, it looks good. Let's go. Let's move on. One of my colleagues, Michael Porath, Posen, is working on a project where he was doing some GIS kind of stuff, history. He's playing with a map, and just the thing I want to show here more is how convenient this becomes to just kind of like, oh, this is too big and it's behind the code. Let's just move it around. This when you're prototyping and he picked these colors and I think they look good. So, but for the sake of example, you might decide that you want some other colors. And you go through, and I'm more of an engineer than a designer. I'm trying to learn, but right now I'm just clicking randomly. So so these are. I have one more data viz example. As another part of that same graphic about our D3 group, put together a big grid of all of the people in our meetup, and we use the avatars. So these are all SVG like image links to the meetup thing. The data comes from the meetup API. It's not live, like I'm not pulling the meetup API live here, but it did come from there. And I wanted to have like this little fisheye interaction because Mike Bostock made a nice fisheye plugin, and I want to try it out. And so this was really nice to just kind of throw these all in there, put in there and watch it work. And let me do something. Another thing for rapid development is that you might not want to use a whole data set because it's 500 images. Manipulating that gets slow. So maybe we'll do like 100. So you can actually see the effect. And then you can play with, the radius of the fisheye to get it to where you want. If you only want small, the fisheye has these couple parameters. Maybe you want to distort more, distort less. So this really, I think, helps kind of understand the range of possibilities. Yeah, I'll share. So another thing, kind of departing a little bit from data viz, but I think it's actually more related than it may seem, is optical illusions. I came across one on Twitter or something, and I was like, oh, this is cool. This is not an optical illusion. Like, your eyes are not deceiving you. I'm going to make this into an optical illusion for you soon. So, I gotcha. No.
Actually, there is a little bit.
I mean, this is an optical illusion. No. So, I noticed though that it was just a bunch of squares rotated in a particular way with some properties, and I was like, well, I can draw squares in an array. Like, that's what I do every day when I plot bar charts, and they're rotated. So I remember I really liked trigonometry, and it was always useful for making games and putting things in circles. So I put the squares in a circle, and I have all of these parameters, and to end up getting this to work, you need to do a couple of things. So I'm gonna change, like every other square should be black and white. Also, the squares shouldn't be filled in. We can just kind of have their the fill opacity lower. And then you need to rotate them in a particular way to get this where it kind of looks like they're all spiraling, right? But you saw that they're concentric circles. All I did was rotate them. So, but there's all these other parameters. Now I'm going to mess up the illusion. but you can see that this space, and sometimes you might get one that maybe this one, like, I don't remember if it looks better or worse than before, or, you know, we can make it bigger or smaller, we can even, you know. So I like this because it allows, you know, to really explore this space and come up with other things. So this was the first one that kind of got me hooked, and here's another one that's not an illusion yet, and there's only one variable we need to change, which is this one. And if you like get motion sickness, like avert your eyes, because this one gets intense. Is it 30 or is it negative 30? Yeah, it kind of like swims. Right? So yeah, I mean, this is a pretty powerful illusion, right? And I think it comes from the high contrast with the black and the white borders and the way it's rotated. But if you change like the background color, you can destroy the illusion or intensify it, depending. So okay, I'll stop subjecting you to this. Final illusion. So also, just as a side note, it turns out that every optical illusion you've ever seen on the internet is developed by one Japanese professor. His website is credited in all of these examples, and you can go there and see. And I've just been like making a hobby of taking ones that he puts up there and trying to recreate them. And you know, this one, I like this example because I applied a gradient to each of these arcs. So you know, this is kind of like using all the pieces of a pie chart, but to, you know, try to mind control you or something, instead of influence you with data visualization. But the interesting thing here was I needed to put gradients. I couldn't like make one gradient that went across all. They all need to be individually rotated. So again, use trigonometry. But in the process, I was getting kind of screwed up results. So I put a little square up there, and like these are all indexed. So I was able to play with, like, you know, as I move around. Oh, no, I need those to be whole numbers. You know, that's how it rotates. And you can see where it kind of flips, because if you do some of this trig or just arithmetic, and then you can't tell, you know, the angle. Anyway, it was a problem. I didn't know why. I put it like in a little a graphical debug thing here, and I could play with it, fixed it as a hack to make it work. But, you know, that kind of thing has frustrated me many times in the past when I was compiling and rerunning, you know, and your shader doesn't work, and you're just like, why? And with things being this fast and accessible, I find that development moves much faster, and you can have way more fun doing your work. It feels more like playing. So another, departing even further from data viz, but I think this is very relevant to, you know, SVG Open and the Graphical Web. There's this guy, the man in blue, I think his name's Cameron. He made this really cool little toy in SVG and JavaScript, and it's just like a fun, you know, fun effect. And I thought, this blob thing is so cool. I wish I could apply that to my scatter plots or something, right? Like, do something with this. So I wanted to understand it. So I'd look through the source code, try to figure it out. And what he's doing is a lot of tricky arc paths, like SVG paths with curves. So I wanted to understand that, and to be able to, you know, so here, this is just very short code. You see, like, I'm making the D attribute of a path. Where did I set that? Somewhere down here. You know, just making it M, and then some coordinates, and then the A thing. And, you know, I was reading the SVG spec and trying to understand this. But really, the best way I think I tend to learn is to play with things, right? To see how it behaves when you know, go across the other way. You see it flips like that. Like, those are things like I wouldn't have intuited just from playing with it. You can change like the radius. So this is like the second point. So once I got kind of comfortable with that, I was like, okay, you know, that's cool. Let's try to recreate it. So I was eventually able to reconstruct from his source code, like figure out what the math was, and move 2 circles, and you see the black outline makes that effect. If you move the other circle, you can also move it in the Y direction. And then the way it all kind of functions, like how blobby it is and how long it takes to separate, is the radius of this circle. So, being able to, you can now like stretch it way farther than when it was small. And you get these, like so you can really interactively discover, effects that you're trying to make with this interactive way. All right, so let's see. Another part of the Brett Victor video, which was very motivational, was his dealing with transitions and time, right? And this is something we all want to do. We want to transition our bars to grow and shrink, or our paths. And, really, I don't know about anyone else, but for me, I'm a pretty visual person, but computing that much in my head is pretty hard. So I like to be able to see what's going on, right? And here I'm just transitioning this circle to a big square, changing the color along the way. And most of the time when we do animations, we parameterize it. Basically, we just go from 0 to 1, and we transition our properties, right? And, I might want to change it so that the second color is, why is it? Green, horrible, ugly green. And okay, so it ends up that. Maybe we want it to not end up there. We want it to go more in a straight line. See that? And if you have seen the video, you'll know why this is called the Brett Victor button, the BV button, because it shows you, past and future and present all at once. And, you can see, like, before, you don't have to go through the whole process of going from 0 to 1. You can just say, oh, this is going to end up down here, and I'm going to put it back to blue. And you can see what the whole transition is going to feel like before you even do it. So this also, one thing I haven't really mentioned about this project is what it's actually doing here is it's evaluating JavaScript, or you can click the CoffeeScript button and write CoffeeScript, and it's using eval, which is considered evil, but it works really well. And it's, modern technology has got so fast that if you just crash, you just, you refresh your browser. It's not even a blue screen anymore. And yeah, so we make certain assumptions about the code. And in the earlier examples I was showing, the only assumption I make is that there's going to be an SVG element waiting for you when you write your code. So you can just use D3, select that SVG element. It's the only one on the page, and you start appending stuff, you're good. In this one, I have a couple functions. Basically, you need an initialization function and a run function. And what this run function, like the way it behaves, is like the inside of a D3 transition. Yeah. Oh, okay. Oh man, I gotta go faster then. Too much. So yeah, you can basically interpolate things and put all this code, see what you want your transition to be, and then you can take what you learned, just set those parameters to a D3 transition, and you can do things like change the easing function to whatever D3 makes available, and you get the bounce. And this also kind of shows you. All right, so I'm going to quickly do a couple more. This is something a friend made, just kind of for fun, like playing with form, and just kind of looks cool. You can play with various things. There's all kinds of interesting things in SVG, like putting text on a curve that, I don't know, from reading the spec, it's not completely, or not the spec, but the docs, it's not completely obvious what it's going to look like, what it's going to do, but, you can play with it here, and there's like a curve parameter, so you can see, it's not going to fall as much. You can change the amplitude. So this kind of interactive playing, I don't know, really helps me understand what's available to me in these web standards. So besides SVG, you started wanting to be able to play with the other graphical web components. So we have Canvas available. This is another kind of endpoint, makes different assumption about your code, that there's going to be a Canvas element. And we, a friend, Syntagmatic, he made this, Jason Davies, who's a prolific D3 coder, made this nice example, and then we rotated it. When you play with the same code and different parameters, you get some really wild, I mean, this is the same code, just change some of the numbers, and you know, you get kind of like unexpected results. Another thing, someone on the internet suggested try to remake those, you know, those cheap laser lights that they have in some nightclubs, you know, like green things. It makes pattern, these rose petals. And someone posted the links here, like the math behind those, just a couple cosine and sine functions, and you know, you can draw the path or you can move things along. Another friend, Paul, and I started playing with this, just all these numbers here and those functions, and came up with several completely different effects from, you know, in the same space. Like, so exploring parameter space from the same code. Really, we use these for like music visualization stuff, recorded some of this. There's a bunch here, but I want to get to the couple more examples. Also, you know, in D3, there's a couple simulation codes available. There's a flocking behavior, which I think Jason Davies wrote. You know, so I made another view that makes an assumption that you're going to run a simulation, and so you can, like, this has Boyd code in it. There's, you know, the force layout stuff. I think Mike Bostock, I copied one of his examples from his slides and put it in here because I want to understand force layouts better. Because this is only, 75 lines of code when you use his stuff. If you take the if you take the flocking simulation from before and then add the Voronoi function that Mike Bostock also made, you get some really, you know, cool stuff. Just, yeah, really interesting. This is all just, you know, by being able to play with it. And then that blob stuff I told you I was interested in, I ended up using to kind of, you know, I wanted to make some effect, and this isn't really useful for anything yet, but it's kind of fun to, like, do. And I got time for, like, a couple more. So there's also a Canvas version of the simulation because, you know, you can do many more points with Canvas. This is not an optimized Boyd implementation, though. But in my master's research, I did fluid simulation, so I ported, that was like 3D, I ported it to JavaScript, of all things. Canvas, and then you can play with, like, let's just turn the world upside down, reverse gravity, you know. We can change the rest density, and they all kind of go together, make it more natural. So yeah, you know, and in simulations, one of the hardest things is kind of restarting. You have to always restart and reinitialize everything if you want to change your parameters to understand what's going on. And this is nice because you can just change them in real time, and maybe if I'm making a game, I want my gravity to be, like, really heavy, and I see what that feels like without having to, like, redo everything. I have just one more really quickly. We also have a WebGL view implemented by my friend Nils, and this is with 3JS, so it just assumes that there's a 3JS context there for you to use. Just kind of show that, and, you know, it could play with, I don't know, some of these. So yeah, I think I'm out of time, but it's tributary. Thanks.
Easier. All right. So you mentioned the optical illusions and and whether or not they were interested in data visualization. Actually, when sometimes when I play with things, I unfortunately get optical illusions. You know, the whole thing of I'm trying to find a good color here, but you put the same color on two different backgrounds and it's just a radically different appearance. Have you looked at all about how to avoid unfortunate, because we're doing this in a programmatic way, right? These data visualizations are often programmatic. You sometimes get effects and it's really just not, you'd rather avoid that. Have you looked into how to avoid unfortunate optical illusions in data visualization?
Sort of. I did the opposite. I was trying to learn how to do it so I could, world domination and all. But there are these, I think it's called the Gestalt principles, right? Which sort of is like a scientific framework for understanding how the eye works and, what elements, like primitive elements, how they work together. And so, a lot of the optical illusions are based on stark, contrast, or the way the gradients and luminance of patterns happen, or things that appear like the perspectives are different. That comes from the way our eyes kind of fill in the blanks for us. So I think studying those, people study those to come up with better ways of representing data, right? More authentic, or not tricking your eyes so much. And you could probably study those to avoid doing the wrong thing as well. Yeah.
What were those called?
I think it's Gestalt.
Gestalt.
Yeah.
I'm interested in the horizontal scroll bar there for changing numbers. What's the range algorithm? What's the min, max? Have you thought about using logarithms? Just talk a little bit about that.
Yeah, I've thought a little bit about it. I'm pretty much going with Gabriel Florit's initial implementation for that. If it's a 0, it just goes from negative or 10 to 10, or 100, negative 100, 100. And if it's any other number, it takes a percentage. Like it just goes from to 1/10 of that number, smaller and greater. So, you could probably do more sophisticated things. And I think in one of these examples, I have this DAT GUI, these sliders, and I do think about that a little more, because you can look at, what properties of number you want to allow. Like, you might only want whole numbers sometimes, but sometimes you want really fine, floating point numbers. My philosophy so far with all of this is to kind of move fast, make only as a few assumptions as possible, to allow as much flexibility and playing around. So I haven't anything where I'm like, okay, I have to categorize and come up with all the different cases. I try to avoid doing that, because that takes a lot of energy, and I'd rather be playing. But I think you could come up with, if you want to try one of those out, this would be a great way, right? Like, for instance, the logarithmic sliders, you might implement one, see how that feels, and then if that's, useful for some section of things, use it for that section of things.
Did you say you used it for layout algorithms? Have you tried graph-based layouts or things like that?
Yeah, so that one of these examples is a force. This is actually using d3.force, which you can use. The assumption in this one is that instead of passing in any a node array that you instantiate, you use this tributary object, so tributary.nodes. And what that does is that when it reruns the code, it doesn't destroy your node list. But I'm just, here it is, D3 force, D3 layout, and then I set the parameters, and then down here somewhere I just call the nodes function. And then this example is not actually the best one, because it's kind of creating, destroying them, and you don't get a chance to change the parameters while you're doing it. But you could totally set up a network graph and links. And I'm personally not yet convinced that force layouts are a good idea for graph visualization, but this is how I might convince myself, is by playing around with it. And
there are a lot of graph layout algorithms. I think that something like this would apply to most graph layout algorithms, even if it's not force-based.
Right.
There are a lot of classifications and being able to play with it in this way would be really useful, I think.
Yeah, definitely. And I think you're really right. And, because the Boyd algorithm, I think it's about to if you were to structure your graph layout algorithm, the API is similar to the force layout, where it takes in an array, modifies it in place, and then you like bind that data to elements, then it could work just as easy. Because this Boyd stuff, or the flocking stuff, is that exact same pattern. It's just, instead of using like simulated physics, it's using some flocking algorithm, and yeah.
Yeah, I'm just a little confused about, like, how do we play with this stuff? Because, like, for example, when I look in the code that you have right there, I don't see like, that doesn't include all the JavaScript libraries, and like, I'm just,
Right.
How do you get started with this?
Okay, so if you just go to engelot.com, click on any of these, you get a blank, or this tributary has this stuff. So what I was saying about the assumptions is, this page will load in a set of libraries that, I've kind of I kind of overloaded. Like, we got D3 even processing now, and backbone underscore, all of these, jQuery, of course. So you can use all of those. And the idea being that you're probably only doing something SVG related in this tributary view. So you select it here. And when you're done, when you're happy, you can just copy paste all of this into your own website, and whatever, if your SVG is just one of many elements in your page, you would provide the selector for that and go on and do your thing. I really see this as a way as a playground for exploring, and because of that, I just include pretty much every graphic related library there is. And then these other ones, yeah, I'm working on more documentation. There is a wiki on the GitHub. But so for like the canvas one, it has a canvas context that it passes into the functions for you, and you just start drawing. You don't have to set anything up.
Thank you very much.
Thank you.